Hello, guys. It's Sunday again. Welcome to Steve's Place. Uh, we're looking forward to a great show tonight on Tesla Coil's lamp and Tesla Coil technology from one of our leaders in the field. And if you want to see this stuff live, be sure you come to our conference that's coming up August 12th to 16th this year. Most likely be at the Crown Plaza. I'll be finalizing everything tomorrow. It looks good. And I'm looking forward to seeing you all there. In the meantime, I want to encourage everyone to become a subscriber to our YouTube channel. It's free, but even better yet, I encourage you to actually join and um, and become a member and get to see everything as it's being posted. You know, um, we have over close to 1,500 videos up there. I'm getting ready to post some more once we get settled into my new digs here. Um, we hope to. Uh, I have like about a couple hundred videos that need to be converted from VHS to DVDs and from there into MP4s and get those up online. We've got a lot of good material from the 80s and 90s, available to us. In the meantime, uh, you can go online and go to get our older videos from like 2025 and 2024. They're available online at a how to. Just go up there and click on it. Um, they're like $99 per year. And there's a lot of great material. You buy once and you have access forever. We also will have T-shirts for sale up there, and we'll be getting a new line up here pretty soon too. So without any further ado, I'm going to bring up Nathan, who will be doing the demonstration and doing the thing, and then he has a guest, Bernie, who many of you know. Uh, so anyway, without further ado, do you want to introduce yourself,
Hello, my
Nathan?
name is Nathan Bunton. I run the Old Man Builds channel. I am the old man that builds. So today we're going to be looking at some Tesla coils, and there's usually a thing that comes with them on how you actually work Tesla coil to Tesla coil. And I wanted to go ahead and let everybody know how resonance works between coils. And what I did is I set up a circuit that you can see. Can't see it anymore. Anyway, that has a primary driving coil, and then the secondaries themselves, they're sitting by themselves. There's nothing else connected to them. But we can make them active in resonance by just putting the frequency of the resonance frequency of the main driving coil into the coils. And that's different than just putting the frequency of the coil. So if you built these things before, you test the frequency of your number two coil and you get a number out of it. Well, that's not actually your resonance frequency. It's the frequency that the coil's set to. So what you have to do is put the number one and number two together and then resonate them. Once you do that, then you have a resonance frequency. That particular frequency is what you need to take over to your other coil and wrap it to be the exact same number. Once you do that, special things start to happen. Every number two coil that you put out there, or secondary coil, will actually put on power to it as soon as you turn on the primary driver. You'll know you have it locked in resonance as soon as you can take that coil itself and turn the amount of energy down, and the energy in each coil on the outside actually picks up an energy. So normally when you see a Tesla coil on YouTube, somebody will put a light bulb right next to it at 9 volts, and it'll barely light up the light bulb. What I actually do is I put it for about a foot and a half to 2 feet away on a secondary coil, and then I'll turn on that secondary coil from my primary driver, and it'll light up the light bulb next to it. And it'll go further away in the field, you'll see than anything else. We'll also find a null zone in every one of these coils that turns on, which basically makes them a bipolar Tesla coil as they turn on. They won't stay as a standard Tesla coil. Right now, in my Tesla coils that I build, my primary exceeds my secondary in how it's set up. So my secondary will be higher than the primary on the very bottom. That way I can get a monopole out of it. Most Tesla coils are bipolar in nature because they leave some on the very bottom, and that makes them a bipolar Tesla coil. Mine are not set up that way. Mine are set up so that they only have one pole. However, in every number 2 coil that comes out, we actually get 2 poles that come out of them, a north and a south, and you'll be able to build a node in the center, which will create a vortex on both sides, which will make the energy active on both top and bottom of the Tesla coil. So you kind of have to watch it when you turn these things on, because sometimes you'll burn your table if you don't watch out where that bottom wire goes. Steve, if you want to put up the video for me, please, so I can show everybody. This right here is a video I did a while back, and I wanted everybody to see where everything is. On the right is my primary driving coil, and you'll see it's in red. What I do have is a secondary ring around that coil. So many of you wondered what those rings do. They give stability to the frequency that comes out of the main driving coil. So if your oscilloscope is showing that it's bouncing around, you put on one of these rings and it gives it absolute stability to the other coils, which means you can hit a more exact frequency. I actually use a capacitor bank to bring frequency into resonance on these things. So I'll show you here.
Put the energy power back on, they'll turn.
You see them all laid out, and you can see that they're all turned on. Now, I only have 9 volts in this thing, and I have right around 2 amps. So normally in that setup, 6 inches, a foot is what most Tesla coils get. As you can see, I'm well over 2 feet away from the second coil, the number 2 coil that's sitting out there. There's no circuits attached to it. There's nothing. It basically runs on the resonance frequency of the main driver out to the secondary coils themselves, and they'll light up. You have to hit this number exact. Now, within, I want to say 10 kilohertz or 4 kilohertz, somewhere in that range is where you want to be. It's really important to put it that way, because most people would think you could just go, hey, any frequency, just put a coil out there and you can turn it on. It's not the case at all. You have to be within a certain bandwidth of that coil that's wound itself. As you can see, when the lights turn off, it looks absolutely gorgeous. You can see the total energy going through everything. It's spread out because they're capacitively coupled. Now, this is something that everybody has to start to understand. Your air becomes capacitance. Usually they say Tesla coils capacitance to ground, and that's true until you put another coil out there. Then coil to coil, they become capacitively coupled. So they're in line with each other. They get resonated one to the next. When you start to put them in geometrical patterns is when you start to see if you have true resonance or you don't. In this one, we're not in geometrical pattern, but you can still see it. There's a null zone in your coil. You notice how it goes really bright? In the center, null zone. Bottom, really bright. Center null zone, really bright. Basically what it's telling you is there's so much energy saturated in the center that it can't pick it up and give you energy out of it. It's not that there's not energy there, it's the most abundant source of energy in the center. As you can see, all the lights still light up well as you do this and you go through them. That one on the end, you can see it's coupled to it. Watch. As soon as it goes back down to where it likes it, it lights up a lot brighter. They're all entangled to each other now. So when you go to a geometrical pattern, that's when it really takes shape. That's when you really start to see what goes on, because as everything is coupled, the field grows stronger. And what you'll find is if you run this for a long time, you're actually going to have to turn down the energy in this. This particular experiment on this day that I did it, I had gotten this thing down to 5 volts and around 1 amp or less on the driving coil itself. That's barely enough to run the transistor that I use for the circuit here. But what happens is the energy is in between each coil at this point. This is the beauty of resonance. It's not that you're picking up any extra energy. What you're actually doing is reducing the impedance in the coils themselves. Because of the correct frequency, it doesn't have to work as hard. It's easier that the energy flows. It naturally wants to flow in itself. But because you put multiple coils together, it couples them. So now you can go from one to the next, to the next, to the next, without having to worry about energy loss or anything else. As you can see, they're all lit up. Every single one of the light bulbs is completely lit, and it looks beautiful in the way that it's done. This is actually how resonance works. Normally you say, well, we have just the coil there, and you can see my coil. Usually say you just have a coil and you put something light bulb next to it. I guarantee you at 5 volts, you wouldn't be able to light that light bulb that far ever, for any coil. It's just not possible. But in doing this, we put them at a distance so that you could see the resonance value and how they pick up in energy. So you can see my capacitor bank right there, right below my Tesla coil. I put it into a ZVS driver. The capacitor bank itself allows me to switch the amount of capacitance that goes into it at all times. So I'm no longer having to play with anything to get it in tune. It automatically, once I turn the capacitor bank on and flip the switches, you'll look at the oscilloscope and I'll be able to tune by every switch that goes on, turn it on and off, and then I'll get a perfect resonance. You see the coil above my number 1 coil right there, the little ring, that right there, like I said, is a balance coil. It allows you to have resonance in your coil, but it makes the frequency very sharp. It doesn't allow your oscilloscope to bounce up and down a lot. It makes everything real clean. Now, there is a trick to doing this. You could put one further out and then closer in as you get to the top. I'm sure many people have seen Tesla coils that look like that. They're looking for a very direct frequency. So if you don't have the frequency correct in these coils, when you build them to the resonant frequency, then it's like two ships in the night. They'll never turn each other on. My personal best out of this is 20 feet. I can turn on the main driving coil at 20 volts on that circuit right there and go 20 feet away to another coil and turn it on. That's the beauty of resonance. And if you take the number 2 coil and ground it out, then the energy works through the ground to give you the resonance frequency until it aligns through the earth. That's even better. That goes to what some of the stuff that Dollard works on in order to get transmission through the earth. That's the way he's getting it. And it's pretty apparent when you work on these style coils. Now, again, this is a modern day Tesla coil. Normally, these are called, are we going to call them Odin coils or Odin coils? Ouidin coils is the name of them. He came up with the coil because he took a bipolar Tesla coil and he modified it. He wanted a monopole instead of a bipolar coil. So what the Odin guy did was he said, okay, let me take the primary, shove it all the way down past the secondary. So you don't have any room to grow a secondary field out the other side. The ground itself becomes now a pump to the coil, and it changes how the coil works. Now, with this coil here, is a modern day Tesla coil, they call it. You have to do a couple things to get it to be the monopole. You have to change the number 1. If you let any of the number 2 slip out the bottom, you have a bipolar Tesla coil. You just don't know it. So in this one, it's required that you have a ground to it in this system, but the circuit itself doesn't matter. You could take that thing and put it in a bipolar fashion and it'll work perfectly with 0 ground in it if you wanted to do it. It's the beauty of working with the ZVS style. But again, we'll go back to the resonance a little bit. We can see how far they're apart, and all the spacing matters when you do this. So as we're working with 9 volts and 2 amps here in this circuit right here, you have to keep it at least about, what is it, a little over a foot. We're probably 16 inches apart right there. And then any coil that you put in after it has to be 16 inches apart and match the exact winding of the other coils that you see on the table. Now I want to show this to you, and I'll let this play a little bit because I want you to notice I have absolutely zero circuits connected to this. As I go through here, I'm going to lift all these number 2 coils up and show you there are no circuits attached here. There's nothing. It's just working on resonance, period. So here we go. I'm going to set the camera real quick. And this is why it's on. So you can see just the number 2 winding. There's nothing else connected to it. That's it. That's the beauty of the way this is supposed to work. You put it back next to it, you see the light bulb light back up. You got another one, the light's on, pull it out. Just the number 2 coil. And then again, we'll put it back. And then it'll light up the light again. Again, geometrical pattern. You can pick any pattern you want. You can run them in a circle around the main driving coil if you like. But this is how resonance works. You can see, again, no circuits attached. Now, if you want to attach circuits to it, you're going to have to take that into account of the frequency of the entire coil. If you want to add capacitors to it, that's fine, as long as it matches the frequency of the driving coil as you add the capacitors as well. So it's absolutely a gorgeous way to look at this and how resonance actually works. You just see number 2 coils out there. You see the energy go out there. You know that we don't have a lot of energy going into the circuit. That's how it's supposed to work. I reduce the impedance of everything in this instead of bringing up the energy. That's the key here. You want the resonance frequency to speak for itself. You don't want a bunch of energy into it. There you go, 8.15 volts. I could tell you right now, you could put a 9-volt battery, 9 volts in your Tesla coil, and you're not getting this unless you have resonance. So this is a verification right there on everything. We're running at 406 kilohertz. You can see how steady it is. It's going back and forth only because I'm standing next to it, and I myself have capacitance in my body. Therefore, it'll do that to you. And you can see the ring going around. It doesn't have to be perfect. It just has to be there. It's the distance between the ring and the number 2 coil. It automatically gives you the closeness to it, so it breaks anything out of it that would fluctuate in the system. That's why you put that secondary ring on there. So yeah, it takes a while to get these coils set that way. It took me a while to, you see all the stuff missing on there on that coil and the length of it. It's because I had to take some of the wire off in order to tune it correctly. And it's a steady signal. It's not jumping anywhere. It's pretty steady right there. So we'll kind of skip ahead real quick and we'll take a look at it again. Again, guys, there's a ton of power out here. They're all entangled to one another though. Every single one of these things. So as we do this stuff, guys, that's resonance. It's an absolutely amazing way to see things. It's not very hard to pull off, but you will have a difference in some of this stuff when you do it. I've gotten this system to work at 9 to 10 volts, but it isn't resonant in itself. It's close, and you'll see it in the light bulb. So if you've ever seen the light bulb go very white and then it gets dark spots in it as it goes, they look like it's turning on and off, on and off. Basically what that is, it's telling you that you're getting a beat frequency between your coils. When you have beat frequency between your coils, you're out of resonance. That's what's going on. It means that you have 2 independent resonant frequencies going on around that area, and it means that you're completely out of resonance somewhere. It's an indicator. So look at the light bulbs here, completely solid. So we'll go ahead and take this thing down right here. And we actually have a setup for a live demo. If you guys would care to take a look at that, if Bernie wants to join in here, we can get that set up. and I'll go ahead and show you guys how this works live.
Turn light off.
There we go. It's set up. You want to go ahead, Bernie? You can take the if it's already seeing, then I'll just turn it on right here. You can take the headset.
Okay. Well, should I turn the light off though? Yeah. Over. Here we go. And we have glow. I believe that's. Oh,
You see it? Ask Steve if he'll just pull up the one picture of the thing while you're doing it.
And that's 7 volts right there.
No, we're a little higher right
A little
now.
higher.
Yeah, I want to make sure you guys can see it.
Oh yeah, it's glowing.
Everybody can see it?
Yeah, yeah. From 2
Okay.
angles.
Can they see the light right there, how they're flashing on and off, or do we need to get a closer picture of it?
Yeah, Steve, if you don't mind making the first camera larger, and then should be able to show the lights as it actually pulses the stream. Oh, maybe. Steve, you there? Large one. One with the screens, please. Oh, I guess not.
Either that, or you can just pull your cell phone, Bernie, and then pull it out.
Yeah.
We'll switch this one if you want.
Oh, they can see. Hard hearing me or hard hearing Nathan now. Okay, actually, yeah, you can see behind my head there, the pink one in the middle, how it is striating behind the opposite direction of me, and that it is pulsing because they're not in full resonance.
You guys need to speak a little bit louder.
Okay, and Steve, do you mind making one of the screens full screen so they can see it better? Probably the one with Nathan in it. Steve? Nope. I guess not. Oh, there we go. Okay, now you can see it.
You
Right
can see the
there.
different lights in between it, how it turns black and.
Yeah, you can see how it's pulsing along like there.
Okay. I'm going to turn it down.
So he's turning it down.
I'm at 10 volts right now.
Down to 10 volts.
I'm at 8 volts.
8 volts.
I'm at 6 volts.
6 volts now. So that's double what we had with the potato power the other day. And so we were missing something to get it to fire up.
I'm now down to 5 volts, Bernie.
We're at 5 volts and still going. We still have light at 5 volts.
And that's the trigger frequency of the actual MOSFET. So let's see if it goes down any further.
So that's the trigger of the MOSFET. Nope.
No, the one turned off.
But we still have 2 going.
I got 4 volts.
We're down to 4 volts and still going.
And we still have a tiny bit of light on. Which tells you that the #1 driving coil right here, working under the MOSFET trigger frequency, is still driving power to both of these because they're capacitantly coupled.
So they are capacitantly coupled, and that is how they were still running despite the only being 4 volts, which is below the MOSFET trigger amount.
I got 4 volts.
Yeah, running off of 4 volts now.
And I still have lights on.
And we still got the lights on. Oh,
3 volts, and I still have lights on.
we're down to 3 volts. I guess they can't see it as well.
They can't see it all that well.
Yeah, it's glowing for us. There you go.
Here we go. We'll just turn it back up so you can see everything back on. Yeah, I'll come and talk to them now.
All right.
You wanna turn
How
back
was
on the
that
light
for a
me?
live demo? You can still see that pink flowing.
So basically what happens right there, guys, is I got the thing down to 3 volts. Now the trigger voltage on my MOSFET itself is 5 volts. So what's happening is um, you're getting the capacitance coupled with the main driving coil at this point. So all the other coils that are outside of it are getting coupled to the main driving coil. So it's adding more power to it. So the circuit itself picks up the power as well. It's because we're using a cap bank to do this. They're going back and backfilling the caps a little bit and pushing power back into this. Kind of like when you, let's see how do I want to say this. When you put on the circuit in order to not get things to explode on you, and you can pull the energy back in, that's basically what we're doing here, is we're using that energy back into the system. We're driving it right back into the capacitors, and they're able to push it back out. So even though that we're only putting in 3 volts, it still recognizes that we're putting in 5 volts. Being that there's still some lit up at a further distance, if we can get it down to 2 volts, well, then we're only a little bit away from it self-driving itself at that point. The capacitance is in the air. It won't last because anything in the air dissipates. It's just a rate of dissipation you have to worry about. So, guys, this is resonance. When you actually get to it, it's less about putting power into a system. It's more about getting your frequency correct. Once your frequency gets correct, the air itself becomes the capacitor. It's what you're working in. They're coupling back and forth, back and forth. So you're able to pull less voltage at a higher amount of frequency, or I say, it's the amplitude of the energy that goes in because there's less impedance in it. Therefore, it flows more freely. That's probably the most appropriate way to say it in a system like this. It was nice to see you be able to turn it on. I wish I could have showed you a perfect angle of it so that you could see it. But as you can still see energy coming out in the coils, you could see that it was working. So, guys, that's energy. That's resonance for you. And as you get the systems bigger, they will build out a little bit. There is a point where you're going to have to go a little further out with some of this if you want to get up into the 40 volt range. If you run 40 volts in one of these coils and they're coupled to each other, like I said, 25 feet is not a problem at 20 volts. That seems like it's wrong. It would seem like in a normal Tesla coil, you say, I got to have 100 volts, 200 volts to get that. It's not true. It means you have a ton of impedance in your circuit. If you're running AC, you have a ton of impedance. Even if you double diode it and make it a DC pulse, you're still having a lot of interference in it. Once you can get rid of that and put it in a pure DC pulse and into the secondary coil, you can get it to go at distance. That's the understanding of Tesla. That's getting everything down. These are modern Tesla coils. They have PVC pipe in them. If we use different material, I can probably double to triple the distance on any one of these very easily. But we chose to use the PVC because it was cheap and easy to use, and it's easy to put out the frequencies the way you want it. Guys, this is resonance, and this is my understanding. I want to thank you all for watching today. If you got any questions, let me know. Let's see. Got some people in the chat here, man, hanging out with me. Yeah, the cool color different lights, those are for the outside lenses on them. So it's just a regular 4-foot light, and they get a little cover that put the different colors onto them. We just see the dude. Yeah, sorry about that, guys. The angle probably wasn't the best. Steve, you have any questions?
Not particularly right now. I noticed that there was a comment here about your lights. Are they the same type of light, or like you have some like red and some are yellow? Just put a plastic coating on that, or what?
Yeah, so basically you can go on Amazon and they have these covers that go over fluorescent lights, and they come in a bunch of different colors. So you could pick any one you want. I pick a little pack of them, and put it on the 4-footers, and they can make them for smaller ones if you want them to. I also have some mercury gas ones that do the same thing, but this is a much cheaper route. It's like $50 for like 6 of them.
And I suppose you wrapped all those yourself, huh?
Yeah, well, it's just, you can see it. It's a little shielding. And I did wrap all the coils myself, by the way. So that's a shielding. I wrap everything myself. I put it on the spindle and I turn it by hand. I don't like any stretched wires on anything. So if anybody buys my Tesla coils or anything like that, just know that I hand wind the thing myself to make sure they come out perfect. I get my wife's glasses and I look like Santa as I'm winding coils all day. But I'll wind 6 or 7 of them in a day, and about 2 hours, 2.5 hours a piece it takes to do them. But yeah, I wind them to the exact frequency, the exact distance, the exact shape of all of them. That way, they're interchangeable throughout every system that I put them in.
Okay. So let's see what we got here. When are you going to make a bipolar solenoid coil and see what you get then for your secondary?
They want to see the pancakes, yes. They've been asking for that one for a while. It's on my list. Bernie's here with me for the next 2 months, and that is on our list. Coming up on the 21st, we get paid, and I will put in the order for the wire and then make them, and then we'll demo them just like this, or hopefully get a better angle for everybody. But we can demo them and show them. I have no problem doing that.
And do you have plans available so people who might want to try to do this themselves
Absolutely, I
can
have a
do
step by
it?
step. Yes, I have a step by step guide on how to do the circuit. Also, it's on my channel. Also, how to wind the coil. I show you how to make a coil winder, and I'll tell you every single step of it. I'll help you put it in AC if that's what you want to do, or a pulse DC. You see Birdie back there. These things are gorgeous, man. But yeah, I even give the STL files away so you can 3D print them all yourself. Yeah, every bit of it I give away for free. If you wish to purchase one without doing the work, by all means, I'll sell you one. I have a site for that on my page as well. But if you want to do it, by all means, I give you every availability to do it.
Okay, and here's a guy makes a comment. He has some extra bifilers he would like to
Nice.
test, I guess.
Yeah, well, those would be cool if you want to send them by absolutely, man. I know he sent over a couple of things for Bernie here, um, and they're really cool. So we've been working with those. But yeah, bifilar coils. I like to run my own spin on things when they first come out. So I like to pull out the patent if there is one, and I'll look at the exact distances and sizes and shapes of the wires. And I have a bifilar coil, but it's stacked. So you have the wire on the top, and then there's a wire on the bottom. They're asking for one with just the 2 wires side by side, just like Tesla did. So that's the one I'm going to make next. The other one I did. The problem is it gets rid of the special part. So when you pull them apart, you get that energy in between there. You don't get that when they're stacked and stuck together. It ruins the whole effect of them, and that's what they're complaining about when they talk about that. A lot of people build them that way, and it's a waste.
Okay. And here's a comment. What kind of development and experiments do you plan on doing?
Development of like what? Like the coils? Like
I imagine that's what he's talking about.
so. Just so everybody knows what I do with these things, I not only show the resonance in this way, I'll actually teach you how to put it in water. So I run a rod down the center, and I don't think people realize there's a lot of energy down it. And I'll put it right in your water table. And what it actually does is instead of when you put energy to water and it tightens it and it makes channels that it can flow in, this one actually takes those channels and pulls them apart. So things flow easier. And it'll show you how you can make plants grow 3 to 4 times as fast when you put this type of energy in there. It's because it's working on the impulse of the inside of the coil versus the pulse on the outside of the coil. It changes the energy completely. It'll reduce the RF in the system completely to the way it'll just go through everything, including lead. And even mineral oil will only stand for so long before it penetrates right through that. So it changes the energy by removing a lot of the stuff in there that creates heat. It comes out very cold. You're able to touch the energy when it comes out of there, but you can put it in, say, water, mud, anything. I put it in my wife's casserole dish, put mud in the casserole dish, put the wire into there, and then the mud will light up 3 feet away. And so, yeah, we do stuff like that so that people understand that. So I teach that on my channel a lot. I call it one wire energy. And it's something that Tesla was doing in Colorado. That's why it bothers me when they cut out the ground in some of these coils, is they're missing a complete understanding of why it was important to have it and the energy that he put through the groundwater itself. That's the only way to light up light bulbs at that distance when he was pulling out for miles, is to put the energy in the water. But it's constructing the energy a little bit different because it's an impulse, which makes it a stronger field and a more long lasting field. So I teach people about that on my channel as well, so that they can do every one of those experiments. I go through them and show them exactly how it works. You can light up, if you connect them in series together with just the rod down the center attached to absolutely nothing, you can light up 6, 7, 8 Tesla coils. You can put it on their primary, their secondary, however you want to do it. They're basically antennas at that point, and it'll keep lighting them up down the line. You can make a whole power station out of it the right way. So I teach people how that one works as well.
Well, if you look at the Colorado Springs note, or I think in the book, Problem of Increase in Human Energy, he shows like he has a like an extra coil, like he has standing there, like you done there,
Mm-hmm.
those extra coils, and he has that out quite a distance from his lab, where he's actually lighting the pointed out of the earth with just that,
Uh-huh.
just what you're showing there, you know. Um,
Well, see, one of the hidden designs about Tesla is the primary's on the wall. When you see that picture, just like your guest last week said, the primary winding's on the wall on the outside, the secondaries are on the inside. Well, there's multiple secondaries on the inside. And when he did Colorado Springs, he put a rod down the center. So, yeah, he got into the water table big, and a lot of people think it's just grounding. It wasn't. It's the energy passing through the water in the ground. So, if I go into your water table where your well is or something like that, wherever the water travels through in the earth is where this energy comes out. If you put 1,000,000 volts into that, 6 miles, 7 miles is absolutely nothing. It's easy to light up a light bulb just by touching it to the ground. Fluorescence will do it.
and
I
and
did it. Go ahead.
there's actually photographs of Tesla doing that, holding his light bulbs to the ground and everything in Colorado Springs. And there's a lot of. I used to. I had a museum which was about, I don't know, less than a half a mile from where Tesla had his lab at.
Mm-hmm.
So I'm kind of really got into that. And the one thing he puts in his Colorado Springs note is the distance from the water main, okay, in Colorado Springs to his coil, you know, and that's how we know the real location of his thing is because it had to be within an arc, okay, of that
Mm-hmm.
water main. So, yeah, and he also took and dug a pit and put so many pounds of copper in that thing, copper sheets and everything. Of course, all that stuff disappeared when it was all sold for the sheriff's sale to settle over the debts he had, you know,
Mm-hmm.
after he left Colorado Springs. So,
Yeah, I agree. Yeah, I think there was an understanding missed there. People think it's just simply the grounding effect. It's not. As a matter of fact, it's something that I tell people all the time. They say they want free energy. It's really simple. It's a screwdriver effect between an anode and a cathode. So if you look at Wardenclyffe and just take it as a big grounding rod, you're cutting down the distance between the high voltage in the sky and the magnetism in the ground. And in that, if you put a capacitor in between it, you pull out energy all day long. Even the Great Pyramids are basically just big capacitors once you understand the materials that are in them. It's a pretty simple effect, and it's very effective. You can pull energy all day long, and it wouldn't be anything to the earth.
Hmm. Yeah. I've always I've learned a lot about Tesla. I've been just building coils. Um, I've helped build them out of junk. I mean, pure junk. Like we use the you know, sheets of metal we would find around the lab, and would have them hooked up, opposing each other, and we'd always have them soaked in oil, like motor oil.
Okay,
So to make our capacitors, we've had
nice.
saltwater capacitors. You know, we've had I don't know. We use the copper tubing out of a refrigerator, uh, for the primary, but you would use like on a water softener. How you pull them out, you have like the fiberglass inside of it,
Uh huh.
and those make good a good form to do your winding for your secondary. And we use like the wire wiring in your house, like number 12 and number 10, whatever you have laying around, just pure junk, and we made them out of that.
Nice. Yeah,
So
as soon as you can get them to resonate, you're good. Doesn't matter what the geometry is of it. I have Tesla coils here that are bipolar coils, and they are a round ball. Is basically what I made it into. Is a round ball. We got it from Sean Colorado, and he showed us how to do this. So you take that shape, you can make it into a Tesla coil, which I do have one and did make. I made one that looks like a peanut. And that one is beautiful in taking regular frequency and making it into AC frequency. When you do it, you could just pulse the DC in there, and then the wave that comes out is AC as it sloshes back and forth, back and forth. But that it's just like two balls put together, and the center comes down a little divot. It's just a peanut, and then we do ones that look like Utrons. So I got all different shapes of Tesla coils, and they all work on the same principle of a normal bipolar Tesla coil. So yeah, I showed that on my channel as well. We do everything. The last one I have to tackle is the Tesla style Tesla coils. That's the last one, and so pretty soon here I'm going to start doing that one.
well, I think building Tesla coils is a great way to an opportunity to be creative. Especially if you don't have any money. The biggest impediment to doing this stuff these days is we used to be able to get these neon sign transformers, and
Uh-huh.
use those, but those are hard to find, you know, and then they won't even let you touch uh, these pole transformers. You don't get your hands on one of those, you know. But
I love it.
I have to
You're gonna
encourage you.
spark
You have to be
gap.
real careful with this stuff, because like if you take like some of these huge industrial grade capacitors, you got to keep a strap on that to keep that grounded because just sitting there, it will charge up
Yeah.
and it could kill you, you know.
Hmm.
So, I remember going up to see a Goku one time, and he had his coil about a foot bigger than Tesla's, and he had one or two wires on the bottom, and the rest that go up. And that fence-like structure you see in Tesla's lab and everything, that's the secondary. We have the primary in the bottom, on the bottom of it. Then above it, it's all secondary. Then everything else is extra coils, And
Nice.
he was quite the performer, and he believed in trick photography a lot. Like you see those pictures where he's sitting calmly reading a book.
Uh-huh.
Well, what that is a multiple exposure, because when it's on, he's not sitting there, But he did that to, for promotional material to get people interested in this stuff. So,
Oh, gotcha. That's cool.
so
I like that. Yeah,
yeah,
we we came up with a way to change the tendrils on the testicle. I should say Sean did. I work with Sean Calderon a lot, and he changed the tendrils in this thing. Usually they send out sword spikes when they go in AC. Well, when you put it in the DC pulse by doing the double diode, what you're actually going to get is tendrils that'll come off. So it's beautiful RF as it comes out like this, and you can see in between it the lines as it goes, and it's completely different. It avoids a lot of things that normal Tesla coils do. But I've even when I first started making Tesla coils, we just took the plumbing from under the sink. You know what I mean? The long tubes, skinny ones. We started with those. Then you go to your paper towel roll, and then you take that right there. You put some lacquer on it, hardened up, sand it real quick, and then put all the windings on that. That works real well. You can use a toilet paper roll as well. There's a lot of little tricks to these things, man. You can even use just a basic hose to it, but it won't give you a whole lot of distance in your energy coming out of it. But you could use the hose going to your radiator if you wanted to.
yeah. And I don't know. Did you ever know Bill Wysock by any chance?
No, I
He's
don't.
no longer with us, but he was king of the coil makers. He worked with Colca, for a while there uh, as a volunteer. But he made a large scale ones. He'd speak at our conference and bring these demonstrations. In '92, he had like a dual coil system where they were throwing sparks back and forth on the stage and everything. And it was great. He built a coil for this guy, Dave Archer, and Dave was using it for painting. And they say his paintings of the universe were probably real, like these are real maps, because the information comes from off the spark. And he did a lot of work with spark gaps in that, you know. Um, and in one, he actually had an enclosed spark gap where he could control the atmosphere in it. He could change like different gases for the spark gap.
Oh,
So
that'd be interesting.
yeah,
Did he
and
have it sealed? It was like a sealed container or something that he did.
yeah, like a container. A sealed container, and you have your your wires coming from each side, and in the middle of that, is where the spark gap would be at, and you could adjust it, and you know, for different sparks and everything. The thing people have to understand though when you're working with these spark gaps is that they're throwing off all kinds of UV at you, so they can. You gotta be kind of cautious about it. Don't be staring at them. You can go blind. Um, Stuff like that. Um, but other than that, you can have a lot of fun when you're working with this stuff. And I think a lot more people need to do it, and they get some creative juices flowing. You know,
Absolutely.
and,
Well,
and
I know
don't
that
rely on AI to do it for you.
yeah. Well, one thing with the spark gaps these days, they're trying to make them as round as possible going into each other, and I think it's kind of a mistake. They don't learn how to cool down their system with their spark gap because they do that. If you preset the cathode and make it thinner than the anode, and you do it in stainless steel, you can zap it once, right? And then it'll set it and it'll make a geometrical pattern inside of it that'll create the correct resonance every time it goes over it. So as the spark gap goes over everything, it creates the same frequency every time in resonance, and then it'll actually cool down your system. So instead of it running at like say 240 Fahrenheit, it'll run at room temperature all day and not heat up anything, and all your parts will stay cool and they'll last a long time. It's isn't presetting your cathode. I don't think a lot of people really understand that. They just run their systems, you know what I mean, with the bolt head or something as simple as they can get instead of learning how the spark gap actually works.
Yeah. Well, the other thing to remember is that on the older cars, the whole ignition system is
Oh yeah,
it's basically an 8-headed Tesla coil,
it
or
is.
6-headed Tesla coil, and
Absolutely, it is.
and most people don't understand that, and I remember working on I'm working on cars and that, you know how the contacts, would get kind of worn, and being poor, I couldn't always afford to get new contacts, and you just have to take a piece of sandpaper and smooth them down. And
I
what
love
good
it.
isn't it?
Oh
you know,
yeah, we're perfect too.
you know,
Yeah, we used to do that, and it's what is a rotary spark gap going on the top cap anyway. So I
yeah,
used to go in there and sand the inside of those things and clean them up. To get rid of some of the carbon, so that it'll keep running real good.
yeah,
Did some of that too.
yeah. So, yeah, you keep your spark plugs cleaned up. Same thing with the spark plugs. You're going to have that migration of metal on those, and you got to either replace them or clean them every now and then. Um,
Yep.
and they really don't emphasize that these days, um, like tuning up vehicles and that. And
Now they just
sometimes
throw everything away.
yeah, changing spark plugs makes a big difference. The other thing that makes a big difference is on your spark plug wires. You know, um, my friend Chuck, he measures like before he puts wires in a car, he'll measure the impedance there, or resistance, and and you'll be surprised. You need to get that below 10 ohms. A lot of them aren't will be all over the place, and some will be like 16 ohms, 20 ohms, and that and then they'll all be mismatched, and it screws you up. You know,
Oh yeah. I remember the
and
kits, they didn't even attach the ends to them. You had to attach them yourself and know how to check for ohms in there. Yeah. That's why they did it. A lot of people just goes, man, why do I have to do this myself? Well, because you have to make sure the distance is right. You have to make sure all the frequencies are right. You have to make sure nothing bleeds out of anything. You know what I mean? Because all that matters in there. It's all a very clean tuned system. It's like, but that's what made the old Chevys so nice. I love my old
so, what do
Chevy.
you use for a spark gap on your coils?
I don't work with spark gaps on them. They're all ZVS or they're Slayer exciters. The
So,
only
do you,
spark gaps that I use in a system is on pulse motors and stuff like that. I can use a spark gap in one. It'd be very easy to set up to take about 5 minutes. So I just found it's easier to teach when people learn it through the ZVS coil because they're able to shift the capacitance around in the cap bank that I use, and they're able to turn things on easier. When it comes to the spark gap, it's pretty much set it and forget it, and not a lot of people get into the learning of it.
so but anyway, I think that's about enough for tonight. And I'm planning on having you come to the conference. So, and if when you come to the conference, you're gonna be bringing some equipment with you. Uh,
Absolutely.
yeah, and people can come and see you and check out your equipment and learn how to do it from you, hands on, right there at the conference. You know, and and did you put up an email or anything for people to contact you?
Yeah, absolutely. I put my channel in the beginning. Let's see, I'll put it up one more time. There's my channel right there in the chat for Old Man Builds. Like I said, all my Tesla coils right there you see behind me. I sell them, I build them. I'll teach you how to build them. If you have any questions, I usually answer right away. Anything anybody needs, if it helps you in making them and understanding them, by all means, I'm here for you. That's what I do on my channel. You can see Bernie with one right there. So yeah, really nice and clean looking. So they work really
Yeah,
well.
I can tell. It's high quality.
They're well worth the price. I was talking to his wife. He doesn't even make anything off of them, she says.
that's the way I guess most of us are.
Yeah,
You know,
do it. You do it for the love of it.
I mean, if I had to make a living off of Tesla Tech, I'd starve. In fact, most of it goes the other way, like off my Social Security. So, but we just moved into this new location, and I'm hoping to stop on the storage and everything. And someone wants to know how much for that one that
How
burner's
much for the
holding.
one I'm holding, Michael? Michael is asking esoteric gold, good friend. He's asking for this. We'll let you know offline, brother. But what do you sell them for?
Well, right now, dude, those things right there, about $240 with the driver circuit with it. We give you a nice Slayer exciter on there. It'll go 40 volts all day. You can literally leave it on overnight if you wanted to. I had some people leave it on for 4 days in a row, and they don't burn down. They don't have mistakes in them. They put out a massive field to them, 5 to 6 feet easy at 40 volts. You can run them anything lower than that if you want to. $240 for the driver and the coil itself. If you want something with the ZBS and you want the capacitor bank with it, it's about $300. And then if you buy multiple things, I take care of you, and you know what I mean. Throw some couple things in for free for you, so that people get nice value for what they do. It's to me, it's all about the learning. If you learned how to do it, if you learned how they work, anything like that. You know what I mean. I've done my job.
I was told to spin around in the comments if you wonder what I'm doing. I was told
Only
to
Bernie.
rotate. There we go. We got model Bernie. Woo! This product, it's worth it. All the science, all the fun.
Sure, some leg there now.
I love it.
Anyway, uh,
Oh,
I'd like to
now
encourage you
one
to come to our
sold.
conference.
Esoteric gold.
Right
10
now,
sold. So one less available, but there are more.
I'm having a special for a conference registration, 50% off if you sign up before the end of the month. So give me a call or go to a website, testatech.info. I have a link there where you can sign up or you can see who's on there. Right now, I think I have about 10 spots open still. And we'll be putting you up there, Nathan, this week. Once you get your abstract and know where to fit you in at. Um, so I think it's going to be a great. And the conference will be at Albuquerque, New Mexico, most likely at the Crown Plaza. And the room rates uh, will include breakfast and a breakfast buffet. Then at night, I always have something, you know. And you can ask Bernie. It's well worth the effort to come to the conference. You know, you have
I'm
a great. I
excited.
guarantee you have a great time. You know, and you get to meet a lot of people uh, for real. So yeah, Crown Plaza, August 12th to 16th. And as soon as I got everything finalized, I'll be putting a link up there for you can sign up for the hotel room as well. Um, Conferences are great, because you get to meet people, and unfortunately, there's not really too many conferences anymore. Everyone wants to do everything on the web, and like the problem with that is like I can't pick up one of your calls and look at it. It's kind of hard to do through the screen.
I understand.
But yeah, and sometimes it's easier when you're looking at something directly to figure things out than it is to try to figure it out through a screen or on a piece of paper, you know. And that's the other thing I'm hoping to bring back is more paper. We need more paper. Uh, there's nothing like the smell of fresh ink, that
Yeah,
gets the brain molecules going. I don't know what it is, but you know, I guess I'm a newsprint guy myself. So,
nice.
but
Yeah, well,
anyway,
they'll be able to see it all live from Tesla Tech, guys. I'll be there, and bring all my coils there with me, and I'll show everybody live demonstrations. So, Steve, thank you for having me on, and I look forward to Tesla Tech this year. I'm going to bring it. I'm going to bring all the show so everybody can see exactly how this stuff's going.
yeah, and if you're carrying stuff, it's better if you drive because you don't have to go through all these security crap. These days they're overly cautious these days. You know, um,
Absolutely.
and
I don't fly, so
And
we're
you're
good.
right. Yeah, you're just right down the highway actually from the conference.
Yep,
So
down the 10, and we're getting to New Mexico easy.
yeah. So anyway, I encourage everyone, and if for those people who can't make it, we will have a live stream, and on the live stream, in addition to what you see on stage, there'll be interviews going on all the time between the presentations. So you'll have a great time. And then I got Old Man Bill shirt, some more. Is that you?
That's me.
Okay, good. And anyway, so I guess I'm gonna call it a night here, and I'll see you. I'll probably see you this week, maybe even, huh? Uh,
Yeah, I'll
and
probably see you when we come out there to help you out doing whatever we're doing.
yeah, yeah, I love this place. I love being out in the middle of nowhere. It's the place to be. And if Vegas starts looking like Minneapolis, there, I don't have to worry about it. I'm 40 miles away.
Nice.
So anyway, y'all have a great time, and I'll see y'all next week. And